Hello everyone. In this video I am going to explain a very interesting data structure which is graph. A graph is a data structure and it's a collection of nodes that have data and are connected to other nodes. A vertex is said to be adjacent to another vertex if there is an edge connecting. The most common graph operations are like checking if the element is present in the graph, then graph traversal, then add elements like vertex edges to graph, and finding the path from one vertex to another. So graphs and the trees are somewhat similar by their structure. In fact, tree is derived from the graph data structure. However, there are two important differences between trees and graphs. First is, unlike trees, in graph, a node can have many parents. Then next is the link between the nodes may have values or weights. So graphs are really good in modeling real world problems like representing cities which are connected by roads and finding the paths between cities. Then modeling air traffic controller system, etc. So these kind of problems are really hard to represent using simple tree structure. Another very popular example I can give is the Facebook. So on Facebook, everything is a node. That includes user, photo, album, events, group, page, comments, story, video link, note, everything. Anything that has data is a node. So every relationship is an edge from node to another. Whether you post a photo, join a group like a page, etc., a new edge is created for that relationship. So now we can see how Facebook uses a graph data structure to store its data. So let's check some of the graph terminologies. Path. A path can be defined as the sequence of nodes that are followed in order to reach some terminal node from the initial node. Then closed path will be called, it's like a path which will be called closed path if the initial node is same as the terminal node. Then simple path is if all the nodes of the graph are distinct without any closed path, then it's called a simple path. And a cycle can be defined as the path which has no repeated edge or vertices except the first and the last vertices. Then comes connected graph. A connected graph is one in which some path exists between every two vertices, and there are no isolated nodes in connected graph. Then comes the complete graph. A complete graph is one in which every node is connected with all other nodes. Next comes weighted graph. In a weighted graph, each edge is assigned with some data such as length or weight. Then digraph. A digraph is a directed graph in which each edge of the graph is associated with some direction, and traversing can be done only in the specified direction. Then loop is an edge that is associated with the similar endpoints can be called as loop. And adjacent nodes are if two nodes are connected via an edge, then the nodes are called as neighbors or adjacent nodes. Then degree of a node is the number of edges that are connected with that node. So next, the graph representation. So we can represent graph using two ways. First is the adjacency matrix. An adjacency matrix is a 2D array of vertices, like each row and column represent a vertex. So if there is an edge between two vertices, then the value in the adjacent matrix will have 1. Like suppose in this graph there is edge between 0 and 3. So in this adjacency matrix, the value for 0 and 3 is 1. Similarly, 0 has edge from 1 and 2 as well. Therefore, the values are 1, 1 here. And from 1, there is edge from 1 to 2 and 1 to 0. Therefore, in the adjacency matrix, we have 1 here and 1 here. And since there is no edge from 1 to 3, therefore, it's 0. Next comes the adjacency list. So an adjacency list represents a graph as an array of linked lists. The index of the array represents a vertex, and each element in its linked list represents the other vertices that form an edge with the vertex. So these are the two main representations with which we can create a graph, or we can store the values of graph. Thank you.